Yeah, so and a very important aspect, know your budget before, and if you know the budget before and it's limited, carry out your phase one, identify the potential risk, and take these measures. Fencing, land use restriction, installing signs, inform the public, go to the schools, inform your children not to enter, and so on. And these are not very costly things, but reduce your risk enormously. Okay, talking about risks, I will now have a model on environmental risk assessment. Environmental risk assessment is part of phase one and phase two. In these two phases, you identify the risks. In the first phase, you identify the potential risk, and in the second phase, you confirm or reject the identified potential risks. So the content of the session is that I first go through the table of content of Model 4. Model 4 is solely devoted to environmental risk assessments. Then I give you a definition of risks, the objective of this lecture, and then I explain the different steps of risk assessment, Tier 1, Tier 2, and Tier 3. The table of content of model number 4 is introduction, and here again, it's in this second section, what is and when to use a Tier 1 risk assessment, what is and when use a Tier 3 and Tier 2, and what data are needed for the 1, 2, and 3 tier risk assessment. Tier 1 risk assessment, we'll discuss the initial conceptual site model, the identification risk, and the methods and the results. And the same here, Tier 2, some words about the improved conceptual site model, the method and the results, and Tier 3, when it's needed. Here you need a detailed conceptual site model, is explained in the module. Then Tier 3 uses models, computer models, and we give a few examples of models, and links are presented in the text to these models. Then we discuss the contact media, the advanced research methods for assessing adverse effects of human health, and then we have the last subsection of section 5 is the ecological risk assessment. And here also this model ends with a section on references. Here many references are given and you can consult them to get more information. So this is the table of content of the Model 4, which can be downloaded from the internet on the website of the Stockholm Convention. The objective of this lecture are to share the definition of a risk, to introduce the differences levels of risk assessment, and when a Tier 1, 2, or 3 has to be carried out, and what data are needed for a Tier 1, 2, and 3. So this is the objective of the model. I will not go into details on the computer models which are available on many websites. So the definition of risk. A risk is an event that when triggered causes a problem. And the risk is the likelihood times the impact. So the likelihood is, what is the likelihood that it occur? And if it occur, what is the impact? What is the consequences of it? And if you carry out a risk assessment, each identified risks should be assessed. So that is a rule. If you have identified a risk, please assess it. Assess it on the level 1, 2, or 3, depending on the phase of your survey. Model 4, Tier 1 or preliminary risk assessment. And this is the risk assessment to be carried out in the phase 1. It's qualitative of direct, potential, and latent risks. What is assessed is the human health risk for the ecosystem and migration risks. The levels of contaminant in soil and groundwater are assessed based on expert judgment. Assumptions are made, and the result of a preliminary risk assessment gives the direction of the detailed site investigation. So with this first risk assessment, you direct your detailed site investigation, your site investigation plan, but it is based on assumption and based on expert judgment. Your conceptual site model, now in a different way, pictured here. Sources, this is a transformer site which leaking oil PCB containing here on the surface. This is the factory. It was a textile factory. They had an accident and it took fire, so that also causes contamination. They had depots on site with contaminated soil. This was rubble being just dumped somewhere else, and this was a pump of fuel. So these are my expected source areas. And this was a large industrial site in Bosnia-Herzegovina. And here I picture the pathways and the receptors. So pathway here is contact human. People walking here on site, they come into contact with the contaminated soil, and it concerns here, so that the pathway is direct contact, and it concerns here the on-site workers. But if we follow the red, the same birds, just the ecosystem, because it's free, the ecosystem get contact with the contaminated soil. They take up organisms that have been impacted by the soil contamination. So here the ecosystem is also a potential risk. And then we follow the dark green line, which is expected that infiltration takes place, and then infiltration is affecting the ecosystem, but also the surface water. Now, in this way, you can present what's happening on site. I will not go into all these lines, but here, for instance, here, the leaking fuel pump, I follow the red line. Ecosystem is the only pathway being identified here, probably because it's fenced and it goes there, it's only on the surface. The blue line is the runoff affected by it, and that will affect the ecosystem. So in this way, you can also present your conceptual site model, which is input for your first risk assessment. Now, this is a system, a very simple system to carry out this tier 1 risk assessment. I have here 5 likelihood classes: not likely, possible, likely, improbable, and very likely. And the impact classes: very small, reasonable, and large, and very large. And as I said, that the definition of risk is the likelihood class by the impact class. If you give them a number, you say, okay, it's possible. So I give 2, and the impact is very large. So it's 2 times 5 or 2 times 6, depending on what you give. So let's do it. Exercise: the preliminary environmental risk assessment. Location: at a large rice farm where pop pesticide and anti-packaging were burned and buried. This is the same example. So the exercise is preliminary assess the human health risk for people working on site. So normally we do that by interaction of the trainees, but I will just continue. So it's very likely that this man comes into contact with the pesticides. So the score is here, and it's reasonable that he may be impacted. So this is for the human health risks done, likely and reasonable. But this can be projected on the graph, and the direct risk are here score between 3 and 6 for the impact and 3 and 6 for the likelihood. Now here, this is the lowest, the latent risks. This is then the risk with a high likelihood but a low impact. And this is a high impact with a low likelihood. Now, and here, these red, these are the mitigations. So if it is a risk with high impact but very likelihood, containment is an option. If it's direct removal. If it is low for likelihood and low for impact, monitoring. If it is low for impact and high for likelihood, also removal is advised. So this is actually a very simple way of getting an idea about the risk, and you can already compare the sites when you do this. Now here again, an exercise to obtain a risk profile with only a site visit, limited site data, and even without site-specific soil and groundwater data. This is very simple. You see here a picture. This is a uncontrolled dump of pesticides, not fenced, not nothing. 2 boys here playing. This is in Tajikistan. They're playing with a pocket knife and they pour into the DDT. So this is the source. The direct contact with the hazardous waste is the pathway, and the receptors are the boys. Without any information, only with this picture, you can tell me what the risks are. These boys will be high impact, high likelihood, only because of the interpretation of the picture and the picture taken on a site visit. So in reaction on the question, the mitigation measure is go to the school in the surrounding and tell children not to play there. And if you have enough money, fence this area and install signs and prohibit using this site. Now we come to the next level of risk assessment, the tier 2. This is the example being used also in the modules. This is a depot of PCB contaminated soil. This is the PCB above the remediation value. So taking the samples, compare the analytical results with the target levels is basically the tier 1 risk assessment. The target levels are always risk-based. So tier 2 risk assessment, when there is a need to establish if concentrations are less than or exceeding site use specific reference values. And these reference values are always risk-based. The input is an improved conceptual site model. The method is comparison of concentration of source pathway samples with the existing reference values chosen. Reference values are risk-based, but the existing reference values depend on the local geology and the historical anthropogenic activities, climate difference, site-specific conditions, country and regional specific assumption and default parameters. Therefore, identify how well reference values represent your local situation in order to select the most appropriate values. And the most appropriate values, there are different sets of reference values available. In my country, we have a set, and in America, USAPA, Vietnam has them. So in the models, various examples are given and various examples can be consulted, but try to select reference values from an area which is like your country. I know that Egypt has some, Morocco is also using, so look for reference values which are close to your situation. For instance, do not use Dutch values because we are in a different climate, our soils are different, and they will not fit into your situation. So the Tier 2 risk assessment, quantification of direct, potential and latent risk, human health risk, ecosystem and migration. The levels of contaminated soil and groundwater are analyzed, and analyzing results are tested against national reference levels. And reference values, preferably national reference levels, should be used. If no national reference levels are present, use international accepted reference levels or reference frameworks, but choose the one which are representative for your situation. Now, I will give you some more details about the Dutch intervention values just to give you an idea how it's built. We have the target levels, and target levels is the baseline concentration value below which components and or elements are known or assumed not to be affected. It's a natural property of the soil. The intervention value is the maximum tolerable concentration above which remediation is required. This occurs, of course, one or more components in concentration equal or higher than the intervention values is found in more than 25 cubic meters and 1,000 cubic meters of soil, of water. So we have, besides the values, also a quantity criteria. So if these values, these intervention values exceed, and they exceed more than 25 cubic meters of soil and more than 1,000 cubic meters of water, then we have to take action. And then we have identification levels for serious contamination are also given for some contaminants. Values of soil and sediments are expressed as concentration in the standard of 10% of organic matter and 25% of clay. I told you that our soil types are different, and so we use the organic matter and the clay content to calculate our target levels, as the clay and the organic matter are the absorption complex of the soil, and they, when they are high, they immobilize contaminants more. Okay. Now we come to the next level of risk assessment. It's a Tier 3 risk assessment. And when are you going to carry out such detailed risk assessment? Mitigation measures demand major investment. When there are major investments demanded, when results are not conclusive, when high stakeholder and public concerns are there, when cost-benefit analysis of mitigation measures is needed, and environmental policy demand legal basis for mitigation. So in this Tier 3 risk assessment is demanded when there are high investments needed. So you want to be sure that the major investment is justified. And what is the input? The input is a detailed conceptual site model. An extra investigation might be needed. So because you are going to use these models, these computer models, you may have to go to the field to do extra investigation, and extra investigation means extra site data. So you need to update your conceptual site model. The method to do this Tier 3 risk assessment is with modeling the fate and transport of contaminants. In one of my first slides yesterday, I showed you the fate and transport processes in soil and groundwater. So this is modeled to get the information for a tier 3 risk assessment. Models include collection of default transport parameters for various soil types. So there are already in these models are also default parameters. The default parameters should be selected and adapted on the site situation. So there may be default parameters, or there are default parameters in your models, but you have to select the correct ones for your on-site situation. And this tier 3 risk assessment needs experts. They also do not carry out this risk assessment. This is done by risk assessment experts. So this is an overview of what is needed, details of a conceptual site model in the tier 3 risk assessment, and the steps to be taken, characterize exposure settings, physical environment, potential exposure of the pollution, chemical source releases, exposure points, exposure routes, and quantify the exposure concentration, intake variables, and then pathway specific exposures. These are the steps taken in such models. Now, this is a screenshot of a model. Quantification of direct potential latent risk for human health and ecological risk and migration risk can be done. The levels of contaminated soil and groundwater are analyzed, and they are tested against national framework, and then risk assessment models are used, such as Rebecca, Sanskrit, Sea Soil, and Vola Soils model. These are all presented in this model 4 with links, but this is really a specialized exercise, and you need to have trained risk assessment people to do this. No, I don't see any questions in the chat.
No, I don't see anything.